Okay, so let's look at this washer method. A couple of homework problems. Number 93, we had two curves here. Y is 4 minus x squared, and the other one was y equals 2 minus x. One is a parabola, one is a line. You can make the picture and see what goes on. But I want to do this, show you that you can do this without actually making a picture. Although I'm not saying you shouldn't. It helps always to understand what goes on. So what you need to do is step one is find the intersection points. And so we put these two equal to each other. So bring everything to the right hand side so that we get all positives here. Then we get 0. So we do this with negative 4 plus x squared. So negative 4 plus x squared. So we will get x squared minus x minus 2. And so this factors as x minus 2, x plus 1. Okay, so we get two intersection points, x is 2 and x is negative 1. So the step 2 is now, we have to determine on this interval that we now have, namely from minus 1 to 2, which one is on top, which one is on the bottom. And so we look at these two guys and just take a test point. An obvious test point here would be 0, right? So this is a test point. And if we plug in 0, I get 4 here. And here I get 2. Okay, so we see then actually this is the bigger one, and therefore we're gonna this one has to come up. The formula for the washer method, so the volume according to the washer method. Don't confuse it with what we do in the lecture on the shell method. Is pi, it's the top curve, right, that, minus the bottom curve squared. We have to square them. Okay, so we need to do, so here we get from minus 1 to 2, the interval that we have, and then we take the top curve, 4 minus x squared minus 2 minus x squared dx. Okay, now we cannot integrate it just like that. Be careful, there are no, so you cannot just, you know, it's integration, you have to be careful, right? There are not that many rules. So we have to expand first. Double product formula, 16 minus 8x squared plus x to the 4th. But when I say the double product formula, and I mean this formula, right? Or if you want with the negative, it goes the negative there. So that's actually what I use the negative for. You can also FOIL this, and the same here, but it goes figure, of course, if you know this formula, right? So the double product is 4x, 2 times 2, right? And then plus x squared. Okay, let's look at all let's write them in descending order here. We have an x to the 4th. Then we have a minus x squared and a minus x squared, so it's minus 9x squared. We have a minus 4. Sorry. I have to be careful with my too many lines here that I misread things. So now be careful. Minus is a plus 4x. And then I have a minus 4, a plus 16 minus 4, that is 12. Okay, and so this is by the power rules. And 1 to the exponent, and then divide by it. Okay, and then we just plug everything in. That's 32 fifths minus 9 times 8, that is 72 thirds, plus 4 times 4, 16 halves, plus 24, and from that we subtract. Now we plug in negative 1, so that is minus 1 fifth, minus plus 9 thirds, which is just 3, right? I could have simplified that already. Yeah, I should have done this here, right? So let's make this a 3, and then this would be already simplified to 24. And this is okay. And then where am I? Plugging in negative 1. So in here I plugged it in there. That was a minus because it's an odd power. Then I get this cancels to 2. Again, I should have done this also here. So and then we have 2 plus 2 minus 12. We plug in negative 1. Okay. And so well, we could work this out. This is actually 33/5. Okay, we have these two to get that. And then we have minus 24 plus 24, that cancels out. We have an 8 here. We have a, and here we have 5 minus 12, so this is minus 7. And this here was 8, and it's 8, so we get plus 15. But the actual number, this is enough. So I'll put this pretty bad. This is enough. You just plug in the numbers. Or you don't even have to actually work them out, just plug them in. Okay, that was number 93, and then the other one was 97. 97, okay. 97. Here the two curves were radical 1 plus x squared and y equals radical 4 minus x squared. So we have to put them equal again. 1 plus x squared equals 4 minus x squared. And we know what to do with radicals, right? We square to get rid of, we isolate radicals, which they are, and we square, so squaring. And then we get 1 plus x squared equals 4 minus x squared. So bring everything to this side. We get 2x squared minus 3 equals 0. So we get x squared. Now, this, if you have a binomial, then sometimes it's easier to solve for x squared, and then you can take x is now the positive or negative square root of 3/2. Don't forget there are two square roots, a positive and a negative one. The ugly thing here is we get a little bit weird endpoints. But that's not really so important, because here endpoints are just things that we plug in all the way in the end. But matters is, of course, we also have to decide which is on top, which is on the bottom. So we have this negative 3/2 and this other positive 3/2. And we have radical 1 plus x squared and radical 4 minus x squared. And we take a test point, but there's a good one that I can choose, 0, right? So this is my test point here. Because in between. So if I plug in 0, I get 1 here. I plug in 0, I get radical 4, that is 2. So this one is the top one. And again, we can graph this to verify. All right, so step 3, last step, is now write down the formula. The volume is pi. Oh, I hope, shoot, I remembered it. There was a pi missing here, right? Because in the formula we have the pi. I'm saying this so often that you don't forget the pi that I forget it myself. So everywhere pi, so pi here, okay? There's a pi here too, okay. Okay, okay, there's something froze here. Sorry, I think my pen froze. What is going on? I cannot move. Okay, sorry about that. So pi, we have the top curve. We decided this is the one, but we have to square it. So it is 4 minus x squared locally, because otherwise we have the difficult integral, minus, and then subtract the other one, 1 plus x squared dx. So we get pi, we get 4 minus x squared, square and square roots cancels, minus 1 plus x squared dx. So we get pi, oh, and the endpoints, I didn't write my endpoints, minus radical 3 over 2, radical 3 over 2, minus radical 3 over 2, plus radical 3 over 2. It gets a little bit nasty here, right? Okay, and so we have 3 minus 2x squared dx, so that is pi 3x minus 2x cubed divided by 3 between minus radical 3 over 2 and positive radical 3 over 2, and then we just have to plug it in. I'm just going to do it to show, this is, you have to show me that you at least know what you're doing here, right? Minus pi times the same thing, but now we plug in negative radical 2 minus 2 times radical 3 over 2 cube over 3. Okay, and that's it. I don't need a